So check that. Yeah, that's
here we go. Okay, thank you again. And in the spirit to really save time, I want to really capitalize what you heard today all day long and around that, keynote talk to really expand on the matter of the interaction between the microbiota and the metabolomic profiling, really to guide us in terms of precision medicine and even a more ambitious goal that is primary prevention, so disease interception. So let me start from a slide that use and abuse, that is the ones that formulated the hygiene hypothesis a few decades ago. A couple of folks that made this really interesting observation that in people that embrace a Western lifestyle, they realized that what has been the main reason why we got sick and died, so infectious disease, just plummeted down to almost zero by implementing specific hygiene interventions aimed at avoiding infections, including sanitation of water, antibiotics that start to really pump up, of course, vaccines and so on and so forth. But during the same timeline, we experience an equally impressive but opposite upward trend of non-infectious chronic inflammatory diseases like neurodegenerative disease, autoimmunity, food allergies, and so on and so forth. So bottom line, who embrace a Western lifestyle would not die fast of infectious disease, die slowly or chronic inflammatory disease until Mother Nature will send COVID and we start all over again. If you want to look at this phenomenon with a negative state of mind, and with the premise that at that time, the paradigm to develop any disease of humankind will require only two things: genetic predisposition and exposure to an environmental trigger. If that's the paradigm, the timeline cannot blame genetic mutation to be responsible for this acceleration of chronic inflammatory disease too short a period of time. And therefore, definitely something in the environment that we're changing too fast to adapt as a species. And then that's pretty much what has been the premise for a long time. But if you want to look at the same phenomenon with a more optimistic, point of view, the old paradigm, if I'm genetically predisposed to develop breast cancer or Alzheimer, is not a given. It's not a destiny. It really depends how you play the genetic cards. So you just heard already that concept. So bottom line, yes, you can be unlucky to have that mix of genes that put you at risk for this disease, but if you do not develop that conditions, most likely depends on your lifestyle. So this is being realized in terms of the paradigm to develop this condition in which, yes, genetics and environment are necessary, but not sufficient. At least another three elements seems to be at play. These two worlds need to interact. Normally, it's not happening because are segregated by barriers, the skin and the airways and so on and so forth. The largest definitely and the more complex being the gut barrier. And if this barrier doesn't work anymore, now you have antigen trafficking that allows instigators from the environment to come into your body and on a specific genetic background to develop something, as you will see in a moment. Fourth element, of course, the immune system. We're talking about chronic inflammation and therefore an immune system that becomes hyper-belligerent, the part of the syndicate. And of course, otherwise I will not be here to talk about this, the microbiome. Now, I put this artificially divided in 5 different domains. They're highly, highly interconnected, particularly the last 3. They influence each other big time. So you have increased antigen trafficking, you will have an immune system will become belligerent. And if you have antigen trafficking increasing, the gut microbiota will go off balance. So you will have dysbiosis and vice versa and so on and so forth. But the key elements that really leads to the concept that you just heard, the unequal one, the personalized medicine at its best, is to appreciate the epigenetic pressure of the microbiome on our genes. It is really the composition and function of the microbiome that decide if, when, why, and how some of our genes will be expressed, repressed, and switching from genetic predisposition to clinical outcome, starting the march to the disease. Of course, from the first slide that I showed you, we made major strides. That slide was a time in which we were convinced any microorganism is an enemy and needs to be fought to get rid of. Now we know pathogens being really the minusculous percentage of microbes, the vast majority being microorganisms that are really trying to find in the human body a niche for a friendly relationship, for mutual advantage. What the microbes got from this relationship is pretty obvious: hospitality and food. What we got out of this? A lot. You know, first of all, we can scavenge nutrients that we can otherwise not be able to from, you know, stuff that we cannot digest, like fibers. The regulation of metabolism is going to be the key of my message here, but you heard already from the guru and metabolomes that, you know, metabolic pathways are really dictated if you stay healthy or you develop diseases. Of course, you know, vitamins that we cannot have enough through diets can come from the metabolism of the microbiota. I told you already that microbes can regulate the immune system, and last and not least, they fight for us against pathogens. After all, penicillin is nothing else than a molecule produced by bacterium to kill another bacterium, okay? But all this implies a fundamental notion. To be a friendly relationship needs to be symbiotic, mutual advantage. As we are not identical genetically speaking, there are no two people, even monozygotic twins epigenetically are not identical. The corollary of the statement is there is not such a thing as a normal microbiome. You can study gazillions of people, you will not find the normal microbiome. What is common denominator is the outcome of this interplay. We all need to have a blood pressure within a certain range. We all have to have glucose levels within a certain range in our blood. How we achieve that? By this interaction between the genome and microbiome that activate specific metabolic pathways that keep us healthy. That's pretty much the story, the way that we understand. You're not going to see this, and it doesn't matter. The point that I want to make is to impress you that no matter what kind of environmental trigger you want to consider, prenatal, where mom sleeps, is exposed to pollution, smokes, drugs, perinatal. Are you born by C-section or vaginal delivery? Preterm, full term. Have you been in the intensive care unit or not? Or postnatal? Will you be eating? Are you stressed? Are you exposed to environmental stuff that can eventually change your directory from your state of health? All this have been proved to change the composition and function of the microbiome. And with that, because of the mutual influence, you may have a loss of barrier function and therefore an increased antigen trafficking that starts that march from genetic predisposition to clinical outcome. Why we have this huge increase in the Western Hemisphere? Because we derailed what it was by the plan of evolution. We're planning to be born by vaginal delivery, to be fed real food, to have no antibiotics that did not exist, little or no infections because the life expectancy 2 million years ago when we started this journey was 14 years. So you die of infection on a dinosaur will eat you. That's it. No time to develop cardiovascular diseases. That brings the microbiome in a balance and should not come as a surprise since the immune system is mainly focused to fight infection. That was the only enemy that for many, many, centuries have been, millennia, I should say, have been doing, that it is the microbiome that program the immune system to decide when to unleash inflammation in a very crucial period of our life, the first 1,000 days of life. That programming will make sure that we unleash inflammation only when we're under attack, and inflammation is turned off when the enemy, i.e. the microorganism, would be out of business because we create a micromilieu that is unfriendly to hot chemicals like cytokine, chemokines, immune cells that will eat you. You will die as a bacterium. The tissue will die, but you will survive as a whole organism. So that's important why inflammation needs to be turned off when it's not necessary anymore. We're not capable to do that anymore because we dramatically change the lifestyle. We're born, much more frequently by C-section. And by the way, it's more than welcome to save life, but not to organize the vacations or the GYN that has to do delivery. We don't feed food to our kids anymore. Use and abuse of antibiotics. This leads to dysbiosis and the outcome that, again, programming the immune system in an appropriate way. How we engraft at the beginning of the microbiome, it seems to be totally chaotic. The first, couple of years, everything's in chaos. Some microorganisms, they come in, and then they leave, and then baby food is coming to the picture. You have another shift until everything calmed down around 2 years of age when the microbiome mature as an adult microbiome. Chaos, no. dating, searching each other, to find that symbiotic relationship that is ideal, that is not a given, and needs to be matured by this searching each other to find the compatibility between the host and the microbiome. Anything that will disturb this search to each other, prenatally or perinatally or postnatally in that famous 1,000 days window, will derail, will disturb that finding each other, and will have tremendous consequences, negative consequences on how we play our genetic cards. I'm going to finish by giving very quickly 2 examples of how the microbiome is capable to really dictate our destiny, mainly autism and autoimmunity. Very quickly, autism, you heard about the gut-brain axis, that there is bidirectional communication between the gut to the brain. But the brain communicating guts was known long time ago. But the gut is capable to communicate the brain and influence behavior and neuroinflammation. That's a relatively new concept. And if you ask, what is the microbiome situation in kids with autism, for example, compared to normal kids, it's different. They segregate. And do we see the same acceleration that I discussed before about this non-chronic inflammatory disease in autism? You better believe it. It's one of the most dramatic and worrisome that I ever seen. In less than 3 decades, we went from 1 in 5,000 to 1 in 58. Male to female ratio 4:1. So if you consider that, 1 out of 3 boys would be out of commission because of autism in the next generation. Scary, scary. It is mandatory to understand what we've been doing wrong to pose some remedies to the matter here. If you look at, the syndicate of what's going on in these kids, that triangulation between gut permeability, immune system, and microbiota stands as well. Indeed, the immune cells that are supposed to put a brake on the inflammation in these kids are underrepresented, and the one that they are supposed to eventually be pro-inflammatory are exaggerated represented. So in other words, these kids are prone to the inflammation. And if you look at their metabolic profile, again, I don't have the time to go through this stuff, but reiterate what you just heard. They have a specific metabolic pathways that are involved. Lipid metabolism, and mitochondrial metabolism, and you can read there. Word of caution here. We are not made all equal. We may be affected by the same disease, so the final destination is the same, but how we got there can be very different from one individual to another. And you heard about this concept of precision medicine over and over again. That applies to autism as well. You may have the path to go to the final destination to mitochondrial dysfunction in a subgroup and lipid metabolism dysfunction in another. That's the reason why the metadata, so the clinical data that needs to be associated with the other omics, is a must. Without this, it's right to pretend to read the book without knowing the alphabet. There is no understanding what is in there. It will be just terrific, because you cannot put this in the context of the clinical situation of the individual. Now we've been entrusted by the European Commission of a very large, I believe it's 60 million euros to do this study on these autistic kids. Important notion here, this is not just to do personalized medicine, but as I was telling you, to have the ambition to predict who over time would develop autism based on genetic predisposition. This is a cohort of 600 babies born at risk with autism because somebody in the family has it, that we follow over time. And we know everything about these kids. We know even if they pick their nose twice a day rather than 3 times a day, everything about the mother, the child, the environment that they live, the way that they eat, and so on and so forth. And with that, we have all these omics that you see there, and each of the yellow point that you see there is identification and possibly validation biomarkers that will tell us who is going the wrong direction. I'm going to finish with this other project that is a little bit more advanced on autoimmunity using celiac disease as a model. By the way, why we want to do celiac disease and autism? Because the prospective study from birth is doable in diseases that materialize early. It would not be doable with Alzheimer's, because you have to wait 70 years for these folks to develop the problem. That's undoable. So even for celiac disease, the gene plus environment necessary sufficient paradigm went under scrutiny because we have seen the same acceleration celiac disease like for the other diseases I told you, doubling every 15 years. And yet, no genetic mutation, therefore not change the grains in this all 40 years. And we see the same acceleration. Once again, it is the microbiome, the driving force. This study that we published, a couple of years ago, it was a proof of concept that if you want to do case control, so in other words, cross-sectional, you take a cohort of healthy individual and you take a cohort of people that have a disease, in this case, celiac disease, you may not be able to find any meaningful results that can be applicable on a clinical ground for disease stratification and a possible primary prevention. If, on the other hand, you have longitudinal data, so in other words, each case is its own control, his or her own control, because you can see before, during, and after the onset of disease, you have much more power to play with. And, what we saw in this case is that kids that eventually end up to, develop, celiac disease had over time, way before the onset of the disease, changing the microbiome composition with enrichment of components of the microbiota and the metabolic profile in the stools that seems to be favoring inflammation, while they lost components, the microbiota and specific metabolic pathways that, on the other hand, they put a brake on the matter. And if you do artificial intelligence, so you start modeling by taking this data, putting together with the metadata and do this multi-omic analysis, and you start to ask the system, can you predict, based on all the data that I'm giving to you, who down the road will develop celiac disease and who will not, and what are the differences? You start to see some interesting data. And you need to do random forest analysis, machine learning, and so on and so forth. So you have to have experts like this yellow fellow there that does this for living. And what you see, for example, that is something that was unthinkable until recent past, you can have with great level of confidence, 70, 80%, the identification of specific component microbiota that will predict who down the road, months after, will develop celiac disease. If this data will be confirmed, now you have a target for intervention to manipulate the microbiota in whatever means you can do it to eventually avoid this derailment and bring these kids back to where they're supposed to do in terms of evolution. Last piece of information I want to give you is if you want to really narrow down to specific metabolic pathways in this specific course, it's not a generalizable concept. We were lucky enough to find one pathway that is the one that you see there for the, the tryptophan biosynthesis pathways and so forth that can predict with 93% accuracy who having this at 9 months of age will develop celiac disease down the road after 2 years. 93%. Now, again, these are numbers that needs to be validated, but can you imagine if that's the case? And by the way, this has also some logic because there are precedents in the literature suggesting that, other chronic inflammatory diseases like MS, rheumatoid arthritis, dermatomyositis, and so on and so forth, Graves, this can predict, who has metabolically a signature related to autoimmunity and who does not. Of course, I simplified something that is much more complex that you heard the entire day, and you will continue to hear here in the afternoon, that each of these pieces are pieces of the puzzle. You cannot complete the puzzle if you have not all these elements interconnected for analysis. If you do, I don't know, a multi-omics, and you don't have the lipidomics, so you don't have the metabolomics, of course, or you don't have, the clinical outcome information in the metadata, you will not be able to interpret the data. So that is the reason why open access, as you heard, immediately sharing of the data, the community coming together to be collegial in sharing rather than keeping the drawer. This information is going to be a must to make this progress for something that, again, was unthinkable until the recent past. I'm going to finish by thanking again for the invitation. This is the crew that I have the privilege to direct and, the funding agency that allow me to share some of the data that I talked with you today. Thank you.